Hi everyone. Today we will discuss about the another one shortest path concept, that is all pairs shortest path, simply called as APSP. So it finds a shortest path between every pair of vertices. That is important. So every pair of vertices in a graph. SSSP means single source shortest path, means we find the shortest distance from single source to all the vertices, right? But in all pairs shortest path, find the shortest path between every pairs of vertices in a graph. So Floyd Warshall, this algorithm is called Floyd Warshall algorithm. So this also follow the dynamic programming concept used to find the shortest path between all pairs of vertices in a weighted graph. Okay, it can handle negative edge weight, but negative cycle are not allowed. So same. In Bellman-Ford also negative cycle are not allowed, and in Floyd Warshall also negative cycles are not allowed. Okay. So it can carry negative edge also. Both Bellman-Ford and Floyd Warshall handle the negative edges. Okay. So what is the dynamic programming concept in this algorithm? The algorithm improves shortest path step by step using intermediate vertices. Okay, we update the distance using find the shortest path based on the intermediate vertices. Okay. So here one formula is there. So distance of I comma j. So this is form one matrix format. So I in ij. So minimum of distance of ik plus distance of kj. So using this is k is the intermediate vertex, right? So ij is a direct path. So we update the shortest path based on the intermediate vertex, that is called k. So distance of so I is connected to I to j, right? I to j. That path is there. One path is there. Some weight is there, right? We update the shortest path. We find the shortest path. Improves the shortest path using some intermediate vertex. So some another one path is there. That is I to k, then k to j. The compare two distance. So which one is small, I to j or I to k, k to j? So which one is small? Use that distance. Okay, if here is 10, here the distance is, and the direct edge distance is 10. Okay, but here the edges is 3, here is 2, total is 5. So which one is minimum? The 5 is minimum. So use that edges. Use that shortest path. So improves, use this shortest path. That is the concept behind this formula. Okay, so ij is a current shortest distance. Update this with intermediate vertex. Okay, algorithm create distance matrix. In Floyd Warshall algorithm, you create the distance matrix initially. Initialize graph weights. Choose matrix first. That is very important. Floyd Warshall means, if remember, you create the matrix first. Okay. Then initialize graph weights. Choose one intermediate vertex k. Update the shortest path using formula. Repeat for all vertices. Final matrix gives shortest distance. Okay. I will explain it on simple example. Okay. So in Bellman-Ford algorithm, you so write the edge list first. Then remember the source vertex is 0. All other remaining vertices are infinitive. Then perform the relaxation. Okay, that is the concept of Bellman-Ford algorithm. So here Floyd Warshall means you create the distance matrix. That is very important. Okay, after you remember this thing, then further move further easily. Okay, this is a simple example. So this contain only 4 vertices. Some directions are, some weight are there. Okay, weights are there. Okay, so first form the matrix. How to form the matrix? How to fill the values inside the matrix? So the initial matrix is called as A power 0. Okay, A0. Clear? Then, how many vertices are there? 4 vertices. So write those vertices in row and column. Okay, 1, 2, 3, 4. Row, and here also 1, 2, 3, 4. Write the vertices number in row and column. Then how to fill this value inside the matrix? That is very important. If in diagonal values represent the self loop, right? 1 1 2 2 3 3 4 4. This is the intersection in the diagonal values, right? So diagonal means 1 1 means that is self loop, but this graph contain no self loop. Simply put 0 in the diagonal. So diagonal 1 1 2 2 3 3 4 4 in get the self loop. In this graph no self loop is there, so diagonal values put it in 0. So put it in 0. Clear? All diagonal values are 0. Then update the distance weight in the edges. So here what is the edge? Here value is 1. Here the value is 2. This is the intersection part of edge 1 to 2. Then what is the weight of 1 to 2? So 1 to 2, any path is there, right? 1 to 2, what is the weight? That is 3, right? So update this value here. Then 1 to here, 1 to 3, right? 1 to 3, 1 to 3, no edges is there. So if no edges means simply put infinity. Okay, no edges means simply put infinite. Then 1 to 4 based on the direction, okay? So this is directed graph. So 1 to 4, these all applicable only in the directed graph. Okay, then 1 to 4. So 1 to 4, so now 1 to 4 here edges is there. So what is the value here? 7. So update this value here. Likewise in 2 1. So any edges are there in 2 1? Yes, 2 to 1 the value is 8, right? 2 to 1 the value is 8. Put that value here. And 2 2 the diagonal values are 0. No self loop in the graph, so put it 0. Then here 2 to 3. 2 to 3. 2 to 3 the value is 2. Then 2 to 4. 2 to 4 no edges is there. They simply put infinity. Clear? How to fill the matrix is clear. If the graph contain no self loop means the diagonal values are 0. If edges are there, then simply write that edges weight inside the cell, the intersection cell. No edges are there, simply put infinity. Clear? Clear, clear. So 2 to 1, that is the edge. 2 to 2 edge. 3 to 1. So likewise you find. So direction is very important. So likewise you fill the matrix. This matrix is called as A0. This is the input to further processing. Okay. Then we find the A1 matrix. So this is A0 matrix filled with the actual value in the graph. Clear? Then how to update in the A1 value? So A1 means we take the intermediate vertex 1. Okay. We find the shortest path through the intermediate vertex 1. We take intermediate vertex 1 as the intermediate vertex here. Then if you take that particular 1 as the intermediate vertex means is simply write no change in the row and column of the 1, because 1 is the intermediate node here, right? In first matrix A1 means 1 is the intermediate vertex here. So we write the same value from A0. So no need change the row and column of 1. Because 1 is the intermediate vertex, no change that value. Simply copy the value from A0. Then we find out those all values, right? Because the diagonal values are 0, you already know this. Just update these things and these things. That is enough to find the A1 matrix. Clear? Okay. Then how to find these values? Just check it out. We find this value first. You find this. How to fill this is 2, right? So what is the edge value? That is 2 to 3, right? So what is the formula here? A0 of 2 to 3. That means you get the value from the previous matrix, right? You take the value from the previous matrix value. Then 2 to 3. What is the A0 of 2 to 3 of? This is the direct edge, right? 2 to 3 is a direct edge. Then we update the weight based on the intermediate vertex. What is the intermediate vertex here? 1 is the intermediate vertex. Then 2 to 1, 1 to 2. So we find this distance also. Which one is minimum? Update that value here. Okay. So 2 to 3 is the vertex. We find that value from the previous matrix. Okay. Now you fill this matrix using the value from the previous matrix A0. Then only you put A0 of A0 of in the formula. Okay. So A0 of 2 comma 3. What is the value here? Okay. So what is the value? 2. The A0, what is the value of 2, 3? That is 2, right? So write 2 here, that is 2. Then less than 2 to 1. What is the value of 2 to 1? 2 to 1 is 0, right? 2 to 1 is 0 plus 1 to 3. That is the intermediate, right? 2 to 1, 1 to 3. So you find which one is minimum. The direct edge or through intermediate. Which one is minimum? So 2 to 1, what is this here? 2 to 1, that is 8, right? Not 0, that is 8. And 1 to 3? 1 to 3 is, that is infinitive, right? Infinitive. This is greater than the value 2. So I simply keep that same value here. So which one is minimum? Write that value. Okay. Then we keep that same value here. Likewise, we find next also. So 2 here, right? No updation is there. The same value is there because this value is smaller than this value. Then find this part. Then find this part. How to find this part? 2 to 4. So what is the 2 to 4 value of A0? That is infinitive, right? Then infinitive, then find the intermediate vertex through the intermediate vertex. What is the intermediate vertex? You find 2 to 4 is infinitive. Intermediate vertex is 1. So 2 to 1, 1 to 4. What is the value of 2 to 1? 1 to 4. Through the intermediate vertex, you reach the particular vertices. Okay. So 2 to 4 direct, you copied the direct edge value from A0. Then what is the value through the vertex, intermediate vertex? In A1 we take 1 as the intermediate vertex. Then find the value 2 to 1 plus 1 to 4. So which one is here? 8 plus 4 the value. So 8 plus 4 is 15. Which one is minimum? 15 is minimum. So update this value here. Okay, instead of infinitive we update 15 here. Okay, likewise you update all the values in the matrix. Clear? Likewise you find all the remaining values. You don't need to find the diagonal value because diagonal value is 0, right? So you find all the remaining values. So you update it with the minimum. Okay. So this is the matrix after A1. This is the output of A1. This matrix is input to the A2. Okay. Here A2 as we take 2 is the intermediate vertex. First, how many vertices are there? 4 vertices are there, right? So in each updation we take one vertex as an intermediate vertex. So in first step A1 as an intermediate vertex. Here A2 as an intermediate vertex. So we no need to. So this is the input. So A1 is the input to the A2. Okay, A0 is the input to the, we update the A1 value based on the A0 matrix, right? Here we update the A2 value based on the A1 matrix. You write the formula. All formula contain A1 of A1 of A1 of, right? Right? Clear? Okay. Then we know that all diagonal values are 0. Now here 2 is the intermediate vertex. So no change in the particular row and particular column. Clear? The same values copied from A1. Okay, the remaining values are we need to find. Remaining 3 values we need to find. We need to update. Clear? So diagonals are 0. We know that. So no need any updation in second row and second column value because 2 is the intermediate vertex here. Clear? Then we find the remaining value only. So likewise you find 1 to 3. What is the, how to fill this value as 5? 1 to 5, you find the direct distance. 1 to 3, what is the value? That is infinitive, right? So infinitive through the intermediate vertex 2, that means 1 to 2, 2 to 3, right? Through the intermediate vertex 1 to 2, 2 to 3. What is the value? We find based on this, okay? So this is direct as, this is through the intermediate node 2. Clear? The concept is clear. So which one is minimum value? 5 is minimum value. Then update this infinity with 5. Then what is next is 7. Then you find like this. This value is highest. So keep the previous value as usual. Likewise you update the vectors. So this is the output of A3. Then you find the this is the output of A2. Then we find the A3. A3 means 3 as act as the intermediate vertex. Then we know that all diagonals are 0. No change in third row and third column value. So just copied from the previous matrix. Right? Copied from the previous matrix. Then remaining values only we need to update. Based on intermediate vertex 3. So what is the value of 1 to 2? Direct values from 1 to 2, that is 3. Through the using the intermediate vertex means 1 to 3, 3 to 2. So we using 3 as the intermediate vertex. You don't go directly 1 to 2. That is here. So this is the directed 1 to 2. Then what is the distance through the intermediate vertex? 1 to 3, 3 to 2. So 1 to 3 is, that is 5. Right? 1, 2, 3, 3 to 2. 3 to 2 is, that is 8. So this value is higher than 3, right? Then keep the previous value. No need to change. Okay. Then likewise you update all the matrices in all the edges. Here A3, here intermediate node as 3. Right? Clear? This concept is clear. So which one is minimum? We update the minimum value in the matrices. So this is the this is the final, this is A3. After update, this take as input, okay. This is the final answer. So in A4 means you keep the, here A4 means all diagonal values are 0. Then in A4, 4th row and 4th column no need to change. You find the remaining values only. Using the intermediate vertex is 4. So using the value from A3. So using the value from A3 matrix. Okay, A3 matrix. So this is the after updation. This is the correct output. Okay, this is the correct shortest distance from all pairs. Okay, all pairs shortest distance. This is the final answer. So the concept is clear. If you have any doubt, please write it in the comment section and clear it. So that is very important. The intermediate concept is important. So which one is highest value? 1 to 2. The 1 to the direct edges is there, 1 to 2. So in A1 we use A1 as an intermediate vertex. So 2 to 5. So sorry, 2 to 4 is there. So 2 is one vertex and 4 is another one vertex. You already know the direct some edges are there, right? So you find the, if you update this particular distance using the intermediate vertex. So intermediate vertex distance, which one is minimum, you update this value. So in first step, A1, 1 as an intermediate vertex. Then what will do? 2 to 1. Then 1 to 4. So which one is minimum? So these all are taken from the previous matrix value. So which one is minimum? These are this, add these two values. Okay. And which one is minimum? Update this value here. So update this value here. Likewise, in A2 step, what is that? In A2, we take 2 as an intermediate vertex. Right? Then in step A3, 3 as an intermediate vertex. Right? Then next 4 as an intermediate vertex. Likewise, if update the all the vertices one by one using the shortest. Clear? This is the Floyd Warshall algorithm using the dynamic programming concept. Clear? So don't forget this thing. In Bellman-Ford algorithm, you write the edge list first, then find the first write the source vertex as 0, all remaining vertices are infinitive, distance as infinitive, then apply the relaxation concept. Bellman-Ford means relaxation concept. Okay, so you perform the relaxation in all the edge list. Okay, then perform next relaxation, then perform next relaxation. Okay, so in every relaxation, the previous one is take as the input to the next relaxation step. So likewise, if no updation is there, that is the final graph. So write the value using the table format. Okay, in Floyd Warshall algorithm, here what is this? The matrix is very important. Okay, you write the matrix. Don't confuse both things. So write the matrix, and the initial matrix is A0, and update the matrix based on the comparison. Which one is minimum? Using the intermediate vertex. That is also very important. Okay. Clear? In each new, you find the A1 means A0 as the input, and you find A2 means A1. You pick value from A1. Okay. Clear? So this is the initial setup. Okay, if no self loop is there, then diagonal values are 0. No edges, put infinitive. Otherwise, you update with the value from the graph. Clear, clear, clear. So, how many vertices are there? 4 vertices are there. Then you perform for A1, first A0 as an initial matrix. Then perform A1, A2, A3, A4. That means A1, A2, A3, A4 means 1 as an intermediate vertex. Then next 2 as an intermediate vertex. Then 3, then 4. Likewise, you find out the final matrix. Okay. Thank you.